Hello students, I hope you all are well, you are stay safe. Since this is the beginning of the session for you, for class 9th and for class plus 1 students, we will start with the very basic. We'll start with physics. Actually, how will you define this subject, physics? One can't actually define physics in actual terms, but still, it is the branch of science that deals with the laws of nature and all the phenomena associated with it. Science means having knowledge, to know, that is science, right? So physics is a branch of science that deals with the study of nature and the natural phenomena. It's a logical subject. So whatever is happening around you, whatever phenomena is happening around you or around your vicinity or surrounding, there must be some phenomena involved, and it is directly or indirectly related to the concepts that we'll be studying in physics, like the formation of rainbow, the dispersion phenomena, splitting up of white light into 7 constant colors, the formation of clouds, the blowing of wind, seasonal changes, the rotation of the earth about its own axis, the revolution of the earth, the formation of day and night. There are infinite phenomena which we can observe. So students, before starting the actual concepts or various branches in physics, and then in this section we'll discuss regarding the basic forces in nature as well, right? Before that, I would like to suggest to have an open mind. Try to understand the concepts, try to appreciate it, try to do it wherever it is possible. Learning by doing, that should be the motto, right? Observe the things around yourself and have that scientific temperament. Have that element of curiosity within yourself. Try to ask questions. Why? Where? When? What? These are the questions which must arise in your mind. Right? So let's start. Physics, there are various branches. I will restrict myself to only few branches in physics. One is mechanics, thermodynamics, electromagnetism, relativity, and then quantum mechanics. So I'll just give brief intro. In higher classes, you will be able to study more complicated terms associated with these branches of physics. So certain branches will be covered in your plus 1 and plus 2 curriculum as well. Now just to give an intro, mechanics, it is the branch of physics that deals with the motion of all those objects moving at low speed. Motion, you are all aware of it. Rest, motion, these two are relative terms. Whenever an object is changing its position with respect to its surroundings with the passage of time, then the body is said to be in motion. And if it is not changing its position with respect to its surroundings with the passage of time or with the lapse of time, then the body is said to be at rest. So, whatever objects are moving around us, be it a car or a train or a bus or bicycle or bike, whatever moving objects we observe around us, the speed are low when compared to the speed of light. Speed of light, as you are aware, it is 3 into 10 raised to the power 8 meter per second. This is the speed of light. 3 into 10 raised to the power 8 meter per second. This is the speed of electromagnetic waves, right? So the body is moving around us, moves with a much lesser speed as compared to this speed. So the motion of all those objects having speed very less as compared to the speed of light. When we study the motion of those objects, that comes under the category of mechanics. So mechanics is the branch of physics that deals with the study of motion of those objects which are moving at low speed. Right? So that's mechanics. Next is thermodynamics. Now, we can divide it into two parts. Thermodynamic. Therm means something related to heat. Dynamics means in motion. So basically, in thermodynamics, we will be studying about heat and the terms related with heat. That is temperature, various scales of temperature, various phenomena involved during the transference of heat like conduction, convection, radiation, right? Several phenomena related to heat and temperature and its effects. We'll also discuss the behavior of a system consisting of maybe gas molecules in a particular condition. So all those studies will come under this branch of physics, which is thermodynamics. So thermodynamics is the branch of physics that deals with the study of heat, temperature, or the behavior of a system consisting of a large number of molecules under a given condition of temperature, right? Then electromagnetism. Electro, something dealing with electricity, charge, right? Magnetism, something dealing with magnetic field. So this is a concept which we will be discussing in detail in +2. So electromagnetism is the branch of physics that deals with the study of electricity and magnetism and their effects. And it will also include the study of electromagnetic radiations, right? Then comes relativity. This is a very, very important branch of physics actually, which was actually developed by Albert Einstein. It is a branch of physics that studies the motion of those objects moving at extremely high speed. Extremely high speed. When I say extremely high speed, I mean bodies moving with speed comparable to the speed of light. Comparable. I mean approximately of the same order that of the speed of light. Right? In such a scenario, in order to study the motion of those objects, it will come under the category of relativity. It basically in this branch will study the invariance, law of invariance of nature, that will study. Here there are certain things when a body tends to move at very, very high speed, and certain peculiar phenomena we can notice. Like one of the phenomena is mass. In junior class you must have studied that mass is constant. Mass is the amount of matter contained in a body which obviously is constant, provided the body is moving at a low speed, right? That is constant, no doubt about it. But in relativity, invariance of mass, we will study that when a body moves at a very, very high speed, then the mass of the body also tends to increase with the increase in its speed. And eventually, when the mass of the body becomes equal, actually when the speed of the body becomes equal to the speed of the light, then the mass of the body becomes infinite. So that's invariance of mass. So in relativity, the mass varies with the motion of the body, right? So here we are talking about the study of the motion of those objects moving at very, very high speed, comparable to the speed of light. Next is quantum mechanics. It is a branch of physics that deals with the study of subatomic particles, sub-elementary particles, submicroscopic particles. Till now you must have heard about, definitely you must have studied about nucleus, the constituent of nucleus, which are nucleons and protons surrounded by a cloud of electrons, isn't it? All the bodies are made up of atoms and molecules. Each atom consists of central positive core known as nucleus. Nucleus is composed of positively charged protons and electrically neutral neutrons, and the nucleus is surrounded by a cloud of electrons which are negatively charged. So proton, electron, neutron, these are elementary particles. But do you know that protons and neutrons are also made up of some subatomic particles like quarks, subquark, downquark? These all are the elementary particles which we will study in higher class, right? There are some other elementary particles as well. There are antiparticles, muons, mesons, leptons, right? Baryons. So, the study of subatomic particles or sub-elementary microscopic particles comes under the category of quantum mechanics. So these are broadly the categorization of physics. These are the basic branches of physics, right? So moving further in this lecture, or rather in this particular session, we will discuss about the basic forces in nature, which I am sure you must have studied in your junior classes. There are basically four forces. One is the gravitational force, the second one is the weak force, right? Third one is the electromagnetic force, and fourth one is the nuclear force. So we will discuss it and try to bring out the essential points of difference between them, right? So let's start with gravitational force. Both in class 9th and class 11th, there's a unit called gravitation. So in that particular unit, we will be studying regarding gravitational force in detail and the importance of gravitational force and the applications. Here, we will just do the intro part, right? So gravitational force exists between two material bodies. Any body is positive matter. So any two bodies, they tend to attract with each other. And that force is known as gravitational force. Every body, every material body exert an attractive force on other material body. And that force is known as gravitational force. Suppose these are the two bodies of masses m1 and m2. And their distances are, the distance between them. So the force between them is given by G m1 m2 by r square. This is the gravitational force. We will derive it. This can be easily verified experimentally. And G is constant, known as gravitational constant. Its value is determined by Cavendish method. That also we'll discuss later on. But for now, you need to remember gravitational force. It is one of the basic forces in nature. And it exists between any two bodies. Any two bodies. Any two bodies exert a gravitational force upon each other. It is always of attractive nature. It is always of attractive nature. It obeys inverse square law. What I mean to say is that as the separation between the two bodies keeps on increasing, the magnitude of the gravitational force between them will keep on decreasing. It is inversely proportional to the square of the distance between the center of the two bodies. So that is inverse square law. It is a central force. Now look, central. Central means this force acts along the line joining these two bodies. This is the line. So attractive, they will tend to come closer towards each other, tend to. So this is the central force. This is the central force. Central force means the force which acts along the line joining the two bodies. This force is not acting in any direction. It is not acting in any direction. It should act along the line joining the center of the two bodies. So that's central force. That's central force, right? These are the weakest forces in nature. Actually, we don't even detect this force. Suppose two students quite close to each other, right? They will definitely exert a force upon each other. But the force is so small and so negligible that it can be avoided. So it becomes prominent, or it is dominant when we talk about heavenly bodies, where the mass of the heavenly body is huge. So in that case, gravitational force plays a crucial role. That also we'll discuss in the later section. So what are the important properties? It is of always attractive nature. These are the weakest forces in nature. They are central forces. It obeys inverse square law. And another important thing, two bodies interact with each other due to the transference of some invisible particles. And those particles, due to which the two bodies are able to interact with each other. So those particles are exchanged. So they are known as field particles. So here the name of the field particle in the case of gravitational interaction is graviton. It is graviton. So the field particle is graviton. Please do remember this. The field particle during the gravitational interaction of the two bodies is graviton. Right? Second is weak force. This is the force which comes into play between a lepton and another lepton, or a lepton and a meson, or a lepton and a baryon. Lepton, L-E-P-T-O-N, lepton. Mesons, baryons. These are subatomic elementary particles, right? What are leptons? These are class of elementary particles that includes electrons, muons, M-U-O-N-S, muons, neutrinos and their antiparticles. So they are leptons. So between these elementary particles, the interaction when it takes place, that is due to weak force. So weak force accounts for the interaction between a lepton and another lepton, between a lepton and a meson, or between a lepton and baryon, right? So weak force. I'll give you an illustration. Look, a neutron can decay into a proton as per the following reaction. That's due to weak force. There, weak force comes into existence. So this is how the neutron is represented, N10. It is having no charge, electrically neutral. This represents atomic number, right? It decays, it is actually known as beta decay, where electron is liberated. So this is the symbol of a proton, and this is electron, E0 minus 1, having negligible mass and negative charge, with the emission of antiparticle. This is antineutrino. So this is beta decay. This is where the weak force comes into existence. So weak force is between two elementary particles. So the distance between them is very, very small. So these are short range forces. They are effective only up to distance of about 1 Fermi. Fermi is about 10 raised to the minus 15 meter. So just imagine. So these are very, very short range forces, right? And these forces, when talking about strength, they are stronger than that of gravitational force. They are much stronger than that of gravitational force. Actually, weak force, it is about 10 to 25 times stronger than that of gravitational force, right? And the field particle over here is neutrino. The field particle over here is neutrino. Third is electromagnetic force. Now here we will discuss electric force, which is also known as Coulomb force, which we will study in +2, and magnetic force. Magnetic force is between the two poles, North Pole, South Pole, okay? And electric force or Coulomb force, it is between any two charge body, positive charge body or positive negative charge body. So you are aware, two like poles repel each other, unlike poles attract each other. Two like charges repel each other, unlike charges attract each other. So basically, when we talk about electromagnetic force, it can be either attractive or repulsive. So simply, if you are talking about electric force, then K is some constant. In place of mass, here it will be charge. It also obeys inverse square law. And in case of magnetic force, in place of mass or in place of charge, we will substitute, K is any constant, substitute the pole strength. Pole strength, suppose it is P1, P2, these are the pole strength. So it also obeys inverse square law. P1, P2 can be considered to be the pole strength of the magnet, North Pole, South Pole, right? So electromagnetic force can exist between two charged bodies or between the two poles of the magnet. It can be either attractive or it can be repulsive. It is also a central force, that is, this force also acts along the line joining the center of the two charged bodies or joining the poles of two different magnets, right? These are much more stronger as compared to that of weak force. Actually, if you talk about gravitational force, weak force and electromagnetic force, the ratio would be 1 is to 10 is to 25 is to 10 is to power 36. This is the ratio. What I mean to say is that weak force is stronger than gravitational force by 10 is to 25 times. And electric force is about 10 is to 36 times stronger than that of gravitational force. And here the field particle due to which the interaction between the bodies takes place. It is due to the exchange of such particles between the bodies due to which they interact with each other. That's field particle. Here field particle is photon. Field particle is photon. This you need to remember. Field particle in this case is photon. Now the fourth force. We have covered gravitational force, weak force as well as electromagnetic force. Fourth force, it is nuclear force. As the term suggests, it is the force which exists inside the nucleus of an atom, right? So it must be also very, very short range force. And these are the strongest forces in nature. Just imagine the constant of nucleons are protons and neutrons. Neutrons are electrically neutral. Proton, both are positive charged, so they must be repelling each other. Gravitational forces, they are negligible between nucleons. So, how are nucleuses able to acquire state of stability? It's because due to the nuclear force. Nuclear force is able to overcome the electrostatic force of repulsion between the protons. So, nuclear force, its magnitude is much stronger than that of electromagnetic force. Right? So, this exists between the nucleons inside the nucleus. So, it needs to be very, very short range forces. Its order is approximately 10 to minus 14 meter. Means nuclear force is effective only up to this distance. It is basically of attractive nature. But later on we will discuss that it contains a small element of repulsion as well. It saves the nucleus from collapsing actually. Right? So it is basically of attractive nature but contains a small element of repulsion as well. They are not central force, right? And most importantly, the field particle in the case of nuclear force. Field particle, as I have told you, field particle is the particle which get exchanged during the interaction of the two bodies, right? That is field particle. In this case, the field particle for nuclear force is pi meson. We will discuss about it in the later section in the higher class, but you need to remember the field particle in all the three cases. And as I am trying to convince you again and again, these are the strongest forces in nature, right? In nuclear physics, we will be dealing with this particular concept in detail. For now, you need to remember this particular ratio. Gravitational force is to weak force, is to electric force, is to nuclear force. The ratio is 1 is to 10 to 25, is to 10 to 36, is to 10 to 38. So try to understand the significance of this particular ratio. The nuclear force is 100 times stronger than that of the electric force and 10 to 38 times stronger than that of the gravitational force. Right? So, in this section, what we have discussed is the various branches of physics which we will be studying in +1, +2 and higher class. And then we have discussed the 4 basic forces in nature, starting from gravitational force, weak force, electromagnetic force and nuclear force. I hope you have understood the topics which we have discussed. This is just the intro part. As we proceed subsequently, we will be dealing with each and every topic in detail. We will discuss the minute aspect of each and every topic, right? Well, we will continue in the next section. Sure.